Welcome to the RCR TV Mobilist series. My name is Jeff Mucci. In just a few days, tens of thousands of highly motivated, overly caffeinated folks are going to converge on Tampa for the Republican National Convention. And for the first time in history, wireless networks are going to play a critical role in the way information is disseminated to the public and the way people communicate at the show. The number of tweets, the number of videos and photographs being uploaded to Flickr, YouTube, and Facebook are going to be, it's going to be unprecedented. Today we're going to be talking about the role that indoor distributed antenna systems are going to play in the DNC and RNC national conventions. Our guests today include John Spindler, who's Director of Product Management for TE Connectivity's in-building wireless group. We have Greg Jacobs, who's CEO of Connectivity Wireless Solutions, and we have David Hartin, David, with Connectivity Wireless Solutions. He's VP of Engineering. Between the team on the call, I believe that most all the DAS venues in Charlotte and Tampa were touched by either TE Connectivity or Connectivity Wireless Solutions. So what I'd like to do is I'm going to start out by showing a chart of the various venues in Charlotte and Tampa that had indoor DAS systems constructed. So what you should see now on the screen is a list of major venues, we're going to go through and talk a little bit about these, and I'm going to introduce some of the speakers and allow them to talk about their role in these indoor DAS systems. So at the Bank of America Center, which is the Panther Stadium, it's going to be the location of Obama's acceptance speech in Charlotte. The equipment there was installed by TE Connectivity equipment installed by Connectivity Wireless. At the Charlotte Convention Center, Corning Access, mobile access equipment was used. It was also installed by Connectivity Wireless. The owner of that system, or the host owner, is Smart City. And you can see the other venues here, and I guess I'm going to open it up to the group a little bit. John, why don't we start with you and maybe just touch on some of the roles you played in these facilities, and then we'll move over and talk a little bit about Greg, you and David can talk about some of the venues that you worked on.
Okay, thanks, Jeff. Well, as you can see from this, the bulk of these facilities, we were actually the equipment provider in these facilities. In a number of them as well, we did provide professional services. So we did the design of the systems, we project managed the installation and handled the acceptance and the commissioning and the acceptance of the systems. Obviously, also, as you can see, in at least one of these venues, we work with Connectivity Wireless as the installation contractor on the system itself at the Bank of America Panther Stadium.
Hey, Greg, maybe you and David could talk a little bit about the role Connectivity Wireless played in one or more of these facilities.
Yeah, that'd be great, Jeff. You know, our firm is a turnkey DAS integrator, meaning that we do everything from data collection to site survey to DAS design to installation and commissioning. And you know, depending on what the project is and who the customer is, we provide one or more of those services. So in the case of the venues you have listed here, as well as multiple others in both Tampa and Orlando, we provided any of the services that I mentioned below. Or a few moments ago, we provided services to get those systems installed. With regards to the convention center, that was a turnkey solution for our customer, Smart City Networks, and the rest of those I'm going to kind of turn over and let David give you some more detail on.
Sure. For most part, we were serving the role of integration partner. So actually physically installing, optimizing, commissioning the systems all over both Tampa and Charlotte. So, you know, I don't know how detailed you want to go into, but there are several other hotels and convention centers that we performed the installation for in both cities, actually.
Yeah, go ahead, and it'd be helpful for, I think, everyone to understand the breadth and scope of DAS deployments in Charlotte and Tampa for the RNC and DNC facilities. So by all means, please share with us some of the other projects you worked on.
We completed the Charlotte Marriott, the AT&T offices, their Brevard Street offices for them directly. Down in Tampa, of course, the Crown Plaza, which will be where most of the press is staying. The Don Cesar Hotel, which is a couple of the carrier executives will be there. And then the Tampa Convention Center, which several RNC events will be held there as well. Okay.
Well, today's agenda, we're going to talk about the RNC and DNC DAS installations in more detail. We're also going to talk about the various business models associated with distributed antenna systems, and finally we're going to talk about some of the future trends. So now that we've talked generally about Tampa and Charlotte and some of the major facilities, John, maybe you could give us a high-level overview of the basic system architecture that's used when deploying indoor DAS systems at large venues.
Yeah, I'd be happy to. So for those who aren't real conversant with the DAS system, I like to liken a DAS system to a fire sprinkler system in a building, only it's for RF or radio frequencies. So you're going to take a centralized source, like a water source in a fire sprinkler system, and distribute that equally throughout a building or a venue through up to small antenna heads throughout the building. So again, very similar to if you think about an analogy of a fire sprinkler system. So what you start with is you generally start with a head end located in either the data center or the telecom room. Now in that head end will be, generally speaking, base stations for a single carrier or multiple service providers, depending on what the requirement is of that particular venue. Those base stations then are fed into the head end of the DAS, in this instance, a host interface, a host unit, which is for the TE spectrum system. From there, then you're converting that RF to optical signal and running it over fiber. Generally speaking, single mode fiber out to, in this instance, IDF closets where we locate our expansion groups. The connection between the head end and the IDF closet is digital, so you get tremendous reach on the system. Now, from the expansion group is then converting optical to electrical, in the TE system, and then running it over thin CATV cabling to remote units. And these remote units can be located either in the ceiling, in close proximity to the antenna, or they can be located in a closet, and then your antennas are going to be a little bit farther away at that point. The remote units are then converting that electrical back to RF and connected into broadband antennas to actually radiate signal, and then obviously take in the signal from the various mobile devices that are being served.
Thank you, John. In terms of the installation process, Greg and David, our estimates are you installed more than 6 million square feet of DAS systems between Charlotte and Tampa. It's probably more than that. Would you mind walking us through the installation process, and then we'll open up to a little more discussion about some of the complexities of designing and installing an indoor DAS system for a large venue that like the DNC and RNC facilities.
Yeah, I'll start with that, Jeff. Again, it's dependent on the customer. In any of these cases, the customer, or I don't believe that in any of these cases the customer was actually the building owner or the end user, which we can cover a little bit later when we discuss ownership model. But depending on who the customer was in each one of these locations, depending on the services that we provided. At some of them, again, we start with the data collection of getting the the native RF environment. Then we look at where getting a physical description through a site survey. Where we'll be able to put head in, where we'll be able to locate the IDF closet to put remote, and then antenna location. And then we go back and do the design. the RF design, and that's back in the office. We utilize Ivy Web for that. From there, we have to gain obviously buy-in from the end customer for locations and design parameters, as well as the end customer, as well as the customer that is hired us. Once that's done, then we go on to the installation project where project management is constructed, and then we execute on that. And these systems, can have 70 or 80,000 feet of cable, and Cat5 and fiber to antennas and many active components. So that all has to be installed for a 3 or 4 to 5 week period, and then we go into commissioning, and that's really where we do the system turn up. The RF source have to be eventually put in for the final commissioning, but at that point the system goes live. That's the full turnkey approach. Again, I'll turn it over to David. David was explicitly involved in the projects that we worked and oversaw the teams putting those systems in or integrating with the customer. So I'll turn that over to David to talk a little bit more in detail.
Sure. I think that one of the most challenging things about these particular systems is that the DASs in most cases weren't there to provide coverage. All the facilities had some level of coverage there. It's really, the DAS is there really to support capacity offload. And so when you design for capacity as opposed to coverage, you have to factor in how much signal is already coming in, so you have to dominate that level of signal. You have to create small little coverage pockets, so your antennas are typically pointed straight down. In a lot of cases, you're trying to use one base station sector just to cover a small section of the stands. So it's a very different approach. There's a significant amount of additional equipment that you would use in a capacity design as opposed to a coverage design. And so there's a lot more things to think about. The other, I won't say challenge, but the other consideration is for stadiums, there's a lot of indoor and outdoor work. So half the cabling is required to be in conduit. You have to weatherproof your antennas and connectors and bowl. You also have to use plenum cable inside the locker rooms and the back of house areas, the suites and things of that nature. So balancing out the appropriate equipment and making sure you're sticking to code was certainly a huge consideration. And then just from an installation perspective, there's a hard deadline. For most DASs, you set a schedule with the customer, you agree to it, and you hit it. But for these events, if there's additional scope or if something doesn't work exactly as planned, you don't get a couple of extra days to complete it. There's hard cutoffs where the Secret Service is shutting down the events, and so we had to be very, very careful that we were planning appropriately and that we completed them on time.
Well, you brought up a good point about the security. Where are we at right now at those facilities? Are they in lockdown mode? Are they all working properly? Kind of give us a current state of affairs with respect to what's really going on in Tampa right now with your team, and where are they at in the process?
So in Tampa, the hotels we're working on and the convention center are all complete. So those systems are on the air. The carriers have plugged in and have optimized, and those are pretty much running steady state. The Don Cesar is the only exception to that, and that particular venue is more for carrier executives and people like that. So the Secret Service is not involved there. In Charlotte, though, that's kind of coming down to the wire. In terms of security, just all of our technicians have to be badged and have to be listed. And we should be commissioning most of those. So the 2 hotels are on the air, and those have been accepted. Panther Stadium has been turned up, but it's still in optimization phase. So there's still some tweaks and antenna moves and down tilts that are going on there today. But it's funny you brought that up, because just today I wanted to add another engineer to Panther Stadium to help wrap a few loose ends up and going through the paperwork process and that sort of thing. I won't be able to get them to start until Friday.
Okay. John, anything you want to add with respect to your teams in either Tampa or Charlotte?
No, I mean they're pretty much in the state that David described. There's always last-minute tweaks to systems that need to be done in terms of antenna optimization, those kinds of things. I would also say in these types of venues that you see a lot of kind of 11th hour changes in venues. You'll see need to add sectors into a venue because there's been a decision that more capacity has to be added into that venue. That will change your design parameters. In one particular venue, we actually had an additional operator want to join in on the venue fairly late in the process, so that they had to be added into the system as well. So these are very complex systems, complex designs that take a lot of coordination to bring off and hit the mark in terms of the turn-up time that's required. And as David said, in these instances, it's definitely very much a hard and fast date of when you have to complete, have the system optimized and accepted, and be out of the venue.
Okay. Weather appears to be on the minds of a lot of people in Tampa. You've got Hurricane Isaac coming close to Florida. The mayor of Tampa has said that he's prepared to I guess turn down the convention if he has to. What are some of the precautions your teams are taking to anticipate bad weather?
Yeah, it's like I mentioned before, in Tampa for connectivity, we have one system that'll be wrapped up by Friday, and then we should be out of there. And it's, we have gotten some requests from the carriers to have people available for maintenance, and so we'll just make sure we plan that appropriately, taking the weather into consideration.
Okay.
Well, I think Jeff, that many of these venues are indoors, so the planning is a little bit easier. But when you get to a place like the B of A Stadium, where you do have outdoor attachment points, lots of outdoor gear, then that's a little different. Of course, that's up in Charlotte, so not as much of an issue as the venues in Tampa.
Okay. Well, I know one of our editors, Martha DeGrasse, talked with Verizon about their Tampa systems. Martha's here in the studio with us. Martha, what kind of precautions were Verizon taking for this convention?
Verizon has backup fuel sources ready to go. The main concern that the company has is just protecting the network. Again, most of their installations are indoor DAS, so what they're going to see more of is not so much a cell site being taken out outdoor as more people coming indoor because of the weather and stressing the network that way.
Okay. Thank you. John, I've got up on the screen some pictures of various installations, both in Charlotte and Tampa. Can you talk a minute about some of the skill sets that are required for the design, engineering, and construction of these systems?
Yeah, well, as I said, the design of these systems is quite complex. All of these systems are multi-operator systems and multi-frequency systems, so you're going to see in almost all of these venues that there is 850 megahertz, 1900, 700 LTE, AWS in these venues, and also most of these venues have deployed 700 LTE MIMO technology, because MIMO is going to give you greater capacity and throughput in the system, which is again key to these particular venues, because in these venues, as David brought up, it's really all about the capacity that you're able to handle, given the amount of people who will be there, and particularly the press working on their smartphones, their tablets, et cetera, et cetera. So capacity design is really critical. Determining how many sectors are required is key in these particular designs. As far as skill sets on the installation side, I think I would throw that question over to David. Obviously, based on that photo in the top of Tampa Bay Times Forum, you clearly cannot be afraid of heights to work on these projects. because as you can see, that is an antenna placed high above the floor of the Tampa Bay Times Forum arena.
So Greg, any comments, or David, any comments on the skill sets of the team actually pulling the cable and hanging these antennas?
Just that you need to have a really strong structured cabling background. You need to be able to appropriately manage space. As you can see from the Bank of America picture there's a tremendous amount of equipment. Take those 2 racks and multiply them by about 20 for that head end. And so you've got to be able to really dress cable well, to be able to label properly and understand what connects to what, because it can really get fairly confusing. You got to make sure that each carrier has their own D-mark to plug into, and really, like John alluded to, you got to be really well at space management. You've got a tiny little room that's just underneath the stands, and you got to make all of this equipment work, and your heat considerations have to be taken very seriously, because you don't want the equipment overheating and shutting down, and there's just a lot that goes into it.
Okay, can you talk, and this is really for the group, can you talk about high power systems versus low power system, and what are the key drivers for whether or not a high power system is deployed versus a lower power system?
I think in general, what you're going to see, Jeff, when we talk about high power, we're talking about a 20 watt or 40 watt type system, whereas lower power is working at 1 watt or somewhere in that range. What you're going to see is lower power systems are generally being used in things like the seating areas to contain signal that's heavily sectorized, because you want to eliminate as much as possible soft handoffs between those sectors. So low power is a better option for that. High power in many instances can be used in access and egress areas of the venues, can be used for fill-in coverage in the outdoor areas, the parking lots, and those kinds of things. And it really is kind of dependent on, one size doesn't fit all. Selecting the right tool for the job and getting that right is really critical. And this is a good illustration of, sectorizing a couple of seating sections, using low power to contain the signal with directional antennas, and really minimizing the soft handoff zone between those sectors.
Okay. Hey, Greg, when you and I were briefing last week, you were talking about the process of getting multiple plans from multiple carriers, and as the integrator and designer, you're trying to balance each of the different carriers' needs and capacity requirements for a system. Can you talk about what that process is really like, and maybe shed some light on when John talked about complexity? It sounded to me more like herding cats. So I wonder if you might be able to shed some light on the process.
It is to some degree. They all for the most part have the same objective, which is to provide additional capacity in these venues. So that's the common denominator. The challenge is that the signal coming in for each carrier can be dramatically different. If they're feeding the site from various cell towers, and they have different output powers at those towers, different antennas and things like that, and the signal coming in is going to be different. Yet you have to design a system that supports the power needs and quality needs for each one of those carriers. So while you may have what you need for one, it just requires a higher level of design, which in turn turns out to require, in most cases, there's more complexity design, and there's certainly more infrastructure involved. From a process perspective, it's really, again, it's about gathering the data of the native RF environment for each carrier, and then taking that into consideration as you do the design, and then it's going back to each one of those carriers if it's going to have multiple carriers on it live from day one, and making sure that you get the approval there. And then it goes even beyond that to the physical requirements that each carrier is obviously going to bring in their own RF source, which is usually one to many BTS racks that certainly have to have the space for it, and I believe the other two folks talked about how space consideration is a real concern. Is that real estate comes at a premium, but then there are also physical requirements around power and climate control that have to be addressed at that point as well when you start putting 15, 20, 30 racks in a room.
Okay. What I'd like to move on to now is before we get into the business case, maybe talk about the investment that these carriers have made. Our estimates are that AT&T has invested $625 million into systems in the area. Verizon, $138 million in their LTE network in Florida. So these estimates are not related to DAS specifically. But we did spend a few minutes talking with AT&T in Charlotte about their LTE deployment and their DAS deployment specifically for the convention. And they said they installed 10 LTE indoor distributed systems as well as 12 outdoor systems. And we got a short clip here we're going to run with AT&T talking about their deployment in Charlotte.
AT&T's goal for the Democratic National Convention is to make sure that folks have coverage from the time they land at the airport to the time they get downtown and anywhere they go for the convention. So we've installed 12 new cell sites. We've got distributed antenna systems around town for street level coverage, and we're also providing coverage in the Bank of America Stadium, Time Warner Arena, and a lot of the hotels and restaurants around town.
So what we're showing now are pictures of some of the Verizon facilities in Tampa. Shows the facilities being built out. I love that shot of those guys trying to lug it. What were they trying to? Was that a refrigerator they were trying to pull up the stairs? I don't know if you guys saw it, but maybe talk a little bit about. And again, this goes into the complexities of installing an indoor DAS system, so it's really invisible to everybody else. But what are they doing right now, if you had to guess? John or Greg?
They're actually, I believe that's a base station that they're trying to wrangle in there. David, you correct me if I'm wrong there, but that's what it looks like to me.
I'm not sure everybody could see that, but that's okay. It was a number of shots of the Verizon deployment in Tampa, and we showed a quick clip of the AT&T spokesperson talking about their deployment in Charlotte. We've talked about the antennas, but I don't think we really talked about the importance of soft handoffs. Why is that important, and what kind of challenges does that create for designing and maintaining the system? David?
Well, so think about a soft handoff really is a CDMA feature where if you kind of think about a cell phone call going from tower to tower to tower as you drive down a road, well, soft handoff is you're actually using resources from two towers at once. So think about you're stuck right in the middle of two. And the challenge with that in a stadium or a hotel environment is that the objective is capacity. We're trying to get more phone calls, more texts, more data to be passed through these systems at once. So if you're taking up the resources of two sectors, so if you see that circle there, they're using capacity resources for Sector 2 and Sector 1. It kind of defeats the purpose. So you want users to be clearly on one sector or the other. And that's why, as John mentioned earlier, you want to use low power so that you're not actually covering the stands on the other side of the stadium as well. Use an extreme amount of tilt, so usually you're pointing straight down as opposed to across. And it's really about trying to maximize your capacity and keep users on one set of resources or the other and not both.
Well, let's move into the business discussion for a minute. And before we go there, who ends up maintaining these systems and monitoring the systems once they've been commissioned and accepted by the carriers?
Well, I'll take that. I mean, typically, again, it depends on who the actual owner of the DAS is. If it's if it is one of the carriers owns the DAS and the other carriers have agreed to join that DAS, then typically it's the anchor carrier that would maintain that system, at least from the DAS perspective. Certainly all the carriers maintain their own RF sources. If it is a third party, which you have a couple here on your list, if it's a third party operator, meaning it's not a carrier, nor is it the business owner, it's somebody that's invested in the DAS in the business, or invested in the DAS to be deployed there, and then is leasing out that to the various carriers, then that would be their responsibility to provide what I would call managed services or monitor and maintain that system. And then it would be up to them. Many of those will outsource that ability to companies like ours that have that monitoring and maintenance capability.
Okay. Well, that's a good segue into the actual business case for DAS. So, John, maybe you could give us a broad overview of the different business models for building and installing and maintaining DAS networks.
There's traditionally three different business models. The most prevalent over time has been either the carrier or the wireless operator actually pays for the DAS, and also obviously the RF source, be it a repeater or a base station. So they cover the costs of the design, the installation, all the equipment, the cabling, etc. And they're the owner of the DAS, regardless of whether it's in a large venue, an enterprise, or what have you. Second, then there are also what we call neutral host providers, companies like Mobility, Crown Castle, American Tower, SBA, etc. Now, they generally get a lease up into a particular property and then do the design on the DAS. They'll bear the burden of all the capital expenditures and the project organization. They're actually obviously adding value to the building owner because they're removing performance risk from that building owner. Then what they do is they're getting recurring revenue through the lease of the system, through the carriers that are willing to participate and come onto that system. Normally that's something that would be negotiated up front between the carriers and the neutral host provider. And of course, the other thing to remember is that the carriers would be involved up front in the design of the system, because unless they're in agreement with the design of the system, they may not be willing to participate on that particular DAS. In some instances, these systems are shared. Some instances, carriers would like to have their own independent systems deployed in a particular venue. It's very much an it depends question based on a number of factors. Obviously, economics is one of them, but there are other issues such as the amount of capacity required in a system, who's going to provide maintenance, those kinds of things. So it's very much mixed, and you can actually see that in some of the information that was provided about these venues. For the RNC and the DNC, there are instances where there are multiple carriers on one system. There are instances where there are multiple systems for independent carriers in each of these venues. So it's very much an it depends question on how that's tackled. And the final business model, go ahead.
I think you're good.
Okay, so the final business model is either the venue or the enterprise pays. This is becoming a bit more prevalent, particularly I think in the enterprise space more than anything, given the amount of smartphones and other wireless devices that are within a building or a workspace. But in this instance, the enterprise actually would contract with either a integrator such as Connectivity Wireless or direct with a vendor to go ahead and design and install a system, and the enterprise then pays for all the gear, the cabling, everything else. Again, critical in this whole process is that the carriers be brought in up front in the process to reach an understanding about what the carrier requirements are for a specific venue in terms of coverage, capacity, etc., and that they have an opportunity to sign off on design as well, so that everybody's comfortable in participating in the project.
Okay. Greg, anything you want to add to the some of the general business discussions?
Yeah, I think John did a great job covering that. A couple comments I would make is when you look at these three models, and to be honest with you, there can be a stew in a specific locations that may have all of these involved in it. But one thing that we see is that the carrier and the venue owner typically have one common theme, and that is customer satisfaction. So, at the end of the day, a hotel or a public venue realizes that a hotel realizes that is dependent as business travelers and convention goers in this case are on their mobile device. If they don't have the ability to use that device while there, then they may not come back. And on the other side of that, the carriers recognize that the last thing they want is somebody depending on their wireless device for their business and not being able to gain access, whether it's coverage or capacity, and get the bandwidth that they need. I mean, that's a recipe for churn for the carriers. And we are seeing the venue and the enterprise getting more involved now because they look at it, it's not somebody else's problem anymore. They see DAS and supporting the wireless device deployments and applications that they're using. They see that more as a core business infrastructure and IT infrastructure for them. So, all in all, it's a good news for the folks, the panelists here, and likely for a lot of the folks that are listening in today.
Okay. We had by the way, if folks on the call have questions, they can submit their questions by way of Twitter using hashtag RCRTV. One of the questions that has come in is specifically relative to Wi-Fi at the DNC and RNC facilities. Could either of you talk a little bit about the role that Wi-Fi is playing in these DAS systems?
Well, if you don't have dead air, go ahead. Go ahead, John.
Yeah, in these facilities, obviously, one of the things that you hear a lot about is Wi-Fi offload. So there is a desire by the carriers to offload some of their data traffic onto associated Wi-Fi networks. And obviously, the smartphones of today, the tablets, they all have Wi-Fi options within them, and some of them are Wi-Fi only, of course. So I think what you're seeing in these venues is you're seeing parallel Wi-Fi systems being installed, again, primarily targeted towards offload of the network, and it might only be 10% of the network traffic on the data side to offload to relieve some of the strain on that network, and also to service those particular people who are carrying devices, for instance, an iPad that is not cellular capable but is only Wi-Fi capable, for instance.
Got it. So in short, the deployments your teams were involved with did not include Wi-Fi at all. Is that right?
That's correct. The TE teams were not directly involved in any of the Wi-Fi deployments.
And Greg, how about Connectivity Wireless?
And that's consistent with us as well. I think that you have to recognize that the planning starts for these events many months in advance. So I think that and I don't want to speak on behalf of any of the carriers, but I think that there are strategies are still being developed to some degree, to various degree with each carrier on whether or not only is it the right thing to do, but what's the right strategy around that.
Okay. We're going to talk about future trends in a minute, but I want to come back to a couple things, specifically different frequencies that operate on these antennas. And John, this might be a good question for you. Talk about some of the complexities of being able to offer 6, 7, 8 different frequency bands on an antenna, and then maybe talk a little bit about where you see the public safety, the difficulties of layering in public safety bands into indoor DAS systems.
Well, as I mentioned before, what's prevalent in these venues is coverage of 850, 1900, 700 LTE, and AWS as well. So 4 different frequencies. These systems all have to be heavily filtered to make sure that there's no issue and interference between them. If 800 IDEN is introduced, then that is something that has to be carefully planned for, because 800 IDEN crosses over on the 850 cell band as well. I mean, the other thing is, as I mentioned before, most of these have been designed for LTE MIMO. Well, MIMO requires a doubling of the number of antennas because you need spatial separation for MIMO. So where you normally would put 1 antenna, now you're going to put 2 antennas probably within, 10 feet apart or so. So all of that has to be carefully planned to mitigate any potential interference issues you might have there.
Okay. Well, we've talked about capacity. We've talked about design criteria. Maybe we talk a little bit about the installation process and labor and cable as it relates to the overall cost of a system. Could maybe you guys give us perspective? Is it cable and labor 50% of the overall DAS system? Is it 25%? In general, what sort of guidance can you give in terms of labor and cable cost relative to the overall cost of a DAS system?
I think that's an it depends question, and I'm sure David and Greg have great viewpoints on this. It is really dependent upon the venue and what the requirements of the venue are, and some of the other things, like does the cabling have to be in conduit, which can really raise the cost of the system, those kinds of things. I always joke around that it takes a lot of wires to do wireless. So cabling is generally a heavy component of these systems. Fiber, CATV, whatever the cable medium is, and you can see the cable component and the overall install component of these systems to be as much as 50% of the overall project cost.
Yeah, and I would say that it can even go higher. I think John hit it on the head there. It really depends on the venue. When you throw in, there are variables in there with regards to conduit, as he mentioned, union labor and things like that can go up. And if those go up, it doesn't necessarily mean that your active components, which is what we would call, the actual DAS OEM product, but that stays static while your actual labor cost can go up. And certainly with design requirements today, we're seeing a little bit of a shift. More antennas, more cabling, more fiber, and that sort of thing. So we're seeing probably that it's when you take what we call ancillary components, meaning not actives and labor, that can be as much as 60 or 70%, or as little as 50.
Okay. Well, we've got about 10 minutes, 15 minutes remaining here, and I want to talk a little bit about future trends. And our friends over at Joe Madden from Mobile Experts was kind enough to share some statistics here. What you see, DAS deployments will double through 2017. And our friend Ian Gillett has talked about this. IGR Research talks about that as smartphones and cell sites get smaller and smaller, you need more and more small cell and DAS type systems, particularly in downtown urban areas and high-rise buildings. So the chart we have here in front of us shows going from roughly 1.2 million to close to 3 million DAS deployments over the next 5 years. John, I'd be interested in kind of your perspectives on DAS growth in general and what you're seeing from your side.
Well, I think we've seen tremendous growth in the marketplace for DAS over the last couple of years. A lot of that has been a focus on larger venues where you're having a high concentration of users, and there's been capacity constraints. And obviously, the introduction of the iPhone was the canary in the coal mine for this in terms of the added capacity requirements in the networks. So that's been driving it. But overall, we do see increasing market requirements for DAS across the piece, not just in large venues, but as we discussed earlier, in enterprises where Wireless is definitely replacing wireline in terms of the communication device of choice, if you will, within an enterprise. University campuses, it's a whole range, hospitality, healthcare, you name it, and they require wireless coverage and capacity. I think there's been a lot of discussion about pico cells and small cells, and you know, as I mentioned before, one size does not fit all. So DAS will continue to remain relevant in the coming years for a variety of reasons.
Okay. So let's move on to some of the future trends. We asked Joe Madden from Mobile Experts to give his kind of his thoughts on some of the future trends and dynamics relative to DAS, and I've got up on the screen now some of his comments. Let's go through these individually as a group and talk about them. The first one being the shift from coverage to capacity. Greg or John, do you have any comments on that? I think we've covered capacity pretty well, but I'd be interested in terms of what you think the next 5 years looks like.
Yeah, I think you've got a couple of different things here. I don't know that I 100% agree that it's shifting just from coverage to capacity. I think it depends on the market you're looking at. It certainly is. Maybe 5 years ago, everybody was looking at coverage, right? And it was about customer satisfaction, whether you're the business owner, the hospital, the carrier, whoever you were. Since capacity has become more of an issue with the carriers, that has shifted a little bit. So they certainly are still trying to address coverage, but to a greater degree with their deployment, their dollars around DAS deployment certainly is around capacity. What we're seeing, though, is still that the enterprise space is still very much after coverage. Now, most of the time they're not educated in wireless, nor should they be, enough to know that, you know what, if they need coverage, they also do need capacity, because we can put the coverage in, but they will soon have capacity issues if say it's a hospital and you've got 1,000 doctors and residents running around using their various wireless devices for patient records and prescription records and things like that. So we see coverage is still a big driver or initial driver in the enterprise space.
John, any comments from you?
Yeah, I mean, I would agree with Greg's comments. The shift towards capacity, again, as I mentioned earlier, has been around large venues with high user densities, not just sports stadiums and arenas, but places like airports and things like that, which have always been kind of high runners for the carriers to look at providing wireless service in. On the enterprise side, many times it's about not being able to get coverage in a basement, in the elevator core, other places like that. So again, enterprise is definitely a mix of coverage and capacity today, but a lot of what's happening in the enterprise is driven still by pure coverage requirements, as Greg has mentioned.
Okay. Well, RCR Wireless has been covering the public safety DAS requirements for or in-building coverage requirements that the federal government's been talking about, and certain municipalities are starting to pick up on codes that require public safety coverage for our first responders in places like hallways and elevators. How do you see DAS fitting into filling that gap that could be mandated by federal level, state level, and the municipality level?
I think the issue with public safety right now is that public safety frequencies are really just a dog's breakfast of different frequencies. You have, UHF, VHF, 450, 700, 800, 900, and the frequency use is oftentimes mandated by the municipalities, and the requirements for a specific geographic region, again, may or may not be mandated by the municipalities. So it's a difficult issue. I think the other thing to look at when you look at public safety being matched with the DAS is that when you're looking at these lower frequency levels like UHF, VHF, 450, they don't match well from a coverage perspective to the cellular frequencies of 700 and up. So you need many fewer antenna points to provide public safety coverage than you'll need for cellular coverage. So it's a difficult match. I think the other question you have to ask is, do you want public safety riding on the same system as the DAS system? Because if the DAS fails, then you've not only lost your public safety, you've also lost cellular communication. So, you know, there's no backup in that particular instance. So there's a lot of questions to be answered here. I think some of this is going to sort out as we move more towards a national public safety band in the 700 area. That's going to be a lot clearer about what's going to have to happen, what the coverage requirements are going to be, and what the need is across the country.
Yeah, Jeff, I would also add to that what we're seeing is, you know, the fire codes today, the same ones that say that you have to have a sprinkler system and all the other things that those phone books have in them, is a consideration for wireless coverage, and it's very specific. So the question is not are the mandates there, it's are the municipalities enforcing them, and we're seeing to a greater degree that those municipalities are enforcing them. So, you know, and or realizing that there is a lot of value, especially in large venues, to have ubiquitous coverage for whatever the first responders type of radio system is. And so, you know, we're seeing a lot more interest in that space. You know, there are a lot of considerations that have to go into it, and I think John touched on a few of them. There's technology considerations. Do you want to have that public safety system or public safety signal ride over the DAS? Well, maybe if it's an enterprise-owned DAS, that may be the driver why they're putting it in, and cellular coverage and capacity is the secondary. If it's a carrier, well, likely not, because with that comes additional expense as well as potentially legal concerns around them owning a public safety DAS, and what if something bad happens and lawyers get involved. So there's a lot of considerations that go into that, but I'd say that we're definitely seeing a trend to where, you know, some sort of solution for bringing first responders the ability to communicate indoors is becoming more and more important.
Okay. Well, bringing it back to the RNC, DNC discussion, the systems that were installed at those facilities, will the carriers or the neutral host provider be able to come back and put public safety networks on those DAS systems?
Yeah, it would be as a second layer, Jeff. So not on the existing infrastructure that we installed, but we could put a second layer that uses, you know, some of the infrastructure such as fiber and things like that, assuming the ownership piece is squared away. But none of them right now have public safety on that I'm aware of.
Okay. Well, we got about 5 more minutes here, and I want to cover a couple key points. The first being the move from passive DAS to active DAS. And let's start by defining what passive DAS is, and then maybe talk about how fast this trend to active DAS is going to take place, not only in North America, but also in Asia and other parts of the world. John, maybe that's a good one for you, given TE Connectivity's global coverage.
Passive DAS generally is defined as a system that effectively is using all passive coaxial cables, maybe with some inline amplifiers, to go ahead and drive coverage within a building. So there really aren't any real active elements within the system. It is still the prevalent technology in many parts of the world where labor costs are low, so the cost of pulling, you know, 7/8" coax through a building up in a riser and then 1/2" from there is relatively low from a labor perspective. So you'll see it in low labor cost markets. Asia Pacific, for instance, is still a market that uses a lot of passive DAS. However, passive DAS has many drawbacks in terms of the amount of loss that you'll get in a passive DAS, and also within its uplink performance, so whatever's radiating from the mobile device back into the network. And, you know, as we've discussed over the last hour, when you start looking at this shift to capacity, which is all about data, not about voice per se, then data many times is about your uplink performance and being able to push stuff from the device up into the network. So I think this is describing why there has been a shift from passive DAS to active DAS. In the U.S. particularly, what is prevalent now is active DAS, and we're seeing a similar shift in other markets throughout the world. There's always a cost component to be factored in here, and again, a lot of that is market to market specific.
Okay, Greg, David, any comments on passive versus active?
Yeah, when I was training our junior engineers a couple of years ago, I would always say that, well, you switch your design from passive to active once you've exhausted your passive DAS link budget. Once you've run out of, you've incurred all the loss you can incur, then it makes sense to step up to an active DAS and take advantage of the fiber optic piece. That's shifted quite a bit now for a couple of reasons. One is the number of frequencies and the amount and the complexity that a DAS has today, that active DASs offer typically better filtering and combining. The other consideration there is, of course, is the loss piece. The combining's better, and when you do a neutral host, active DASs offer each wireless carrier their own specific demarc and plug-in point. If you're doing it passively, it's inconsistent, and you kind of have to engineer an answer on the fly for them. A couple of other reasons why we're seeing that shift.
Okay, well, let's wrap up by talking about small cell, FEMTO, PICO, DAS, a lot of acronyms. We had an editorial webinar that was led by Dan Meyer earlier, or actually it was last week, John, I think you participated in, and one of the questions that came up was, where do small cell networks fit in with DAS, and how does that affect the business model and the cost equation for carriers and enterprise customers?
Well, as I mentioned last week, my viewpoint on this is DAS was doing small cell before small cell was cool. So in essence, DAS deployments are small cell deployments. You're creating a cell site within a venue, within a building, however you want to define that. So it is part of the small cell ecosystem. When you read about small cells, a lot of what you read about is either picocells or remote radio heads. And obviously those are getting a lot of focus in the marketplace today. There are some drawbacks to small cells remote radio heads in that they are generally single frequency, single carrier devices. So when you start looking at what a DAS can bring to the table, a DAS is generally speaking essentially frequency agnostic and can handle multiple carriers, where if you look at a PICO or remote radio head, you'll have to deploy multiple devices in a single coverage area to handle multiple frequencies and multiple carriers. So, my opinion on this particular subject is that what makes the most sense is to marry up some of these small cell base stations like PICOs with DAS, because they're well suited to them from a power level where the DAS does not need all the power that's coming out of a macro base station today. Most of that is attenuated and thrown on the floor, if you will. So all that's doing is creating heat and electrical requirements that aren't needed and requiring space. So, again, marrying up a PICO type of architecture with a DAS makes tremendous amounts of sense to me from an economics and an efficiency perspective.
Yeah. And David, I know that Connectivity Wireless certainly does a lot of work with the carriers, but you do an awful lot of work with the enterprise customers. And one of the things I've heard consistently for the past 3 years is that DAS systems are expensive, particularly for an enterprise that's simply trying to improve coverage. Can you talk about small cells and really the business model from a building owner standpoint? So I own a 20, 30, 40-story building or a 30-story multifamily apartment, and I'm trying to just provide coverage. What's the process I go through to really engineer a system, and how do I think about Wi-Fi, small cell, FEMTO, DAS?
It gets back to clearly defining what your requirements are. If you're primarily a single carrier customer, and that's what you're mainly interested in, well, that can be a lower cost system for you. You might even be able to partner with the carrier to help fund that. If you're a hospital who needs to accommodate several different doctor groups who use several different devices, then I think the ROI for a neutral host DAS makes a lot more sense and is a lot less expensive from their vantage point. Small cells, getting back to what John was talking about, from an integrator perspective, a small cell system is a DAS system. It's antennas distributed out through a building. It's RF sources instead of remotes connected back to a common head end via fiber. And we've done a couple of these. And so, the specifics around the design and how the pieces of equipment connect together vary a little bit, but from an integrator perspective, it's largely the same. But speaking back to your ROI model, the small cells are typically going to be owned by the carriers. You can't just go out and purchase your own small cell and tune it to whatever wireless carrier you like. So you're going to have to work very closely with them, and they're going to make the ultimate decision as to how that gets deployed. So if you want to own your own DAS and be more in control of it, then I think a traditional OEM model such as TE Connectivity brand of DAS makes a lot more sense. So again, it just depends on exactly what your specific wireless needs are as a customer.
Okay. Well, gentlemen, we ran a few minutes over. I just want to thank each of you. David, I know you're incredibly busy. Greg, thank you for your time. John, you've dedicated a couple hours or more to us over the past week, so I'm grateful for your time. This is the RCR TV Mobilist series. You'll see more of these week over week, and where we tackle important and interesting topics going on in the industry today. Today's program was underwritten by TE Connectivity, so thank you, John. We appreciate the support. If you have follow-up questions for us, please email me, and I'll distribute them to John, Greg, or David, or just send us a question by way of Twitter at #RCRTV. Gentlemen, thank you for your time.
Thank you, Jeff.
Yeah.
The organizer has ended the session, and this call will be disconnected. Good.